So this assignment, which is related to momentum and the collision. For this assignment, like first, question 8 onwards we'll do. So in question 8, an object moving north with a momentum of 23 Newton second. It collide with an object which is moving east. After the collision, the objects move off together. Which of the following give us the magnitude of the final momentum? So the momentum before is equals to momentum after. So what about the final momentum? Because the two vectors are perpendicular to each other. So if you need the resultant will be the base square, because horizontal component square and the vertical component, we just have to add them. So it will be 35 square plus 23 square in a root. So 35 square in, just we'll take this in a root. So what will be the right answer? The right answer for this one will be D, as the two of the vectors are perpendicular to each other. In question 9, two objects collide and rebound. Select the row on the table which correct the total momentum and total kinetic energy in inelastic. In elastic collision or inelastic collision, momentum is always conserved, irrespective of type of collision, even it's elastic. But what about the kinetic energy? The kinetic energy is not conserved. So B will be the right answer for this. In question 10, an object moving north um, with the momentum of 23 and collided east. After the collision, the object move off together. Which of the following give the direction? So if you need the direction, it cannot be C or D. Definitely the resultant direction will be in this way. So first we have to draw a vector diagram for this. The vector, any one of the vector you can draw first. And angle with a vertical is shown. So if I draw 23 first, now first I drew 23 and then I drew 35. Okay. So this one is 23, this one is 35. What about the resultant from tail of the first to the head of the last? This will be the resultant vector. And here we have an angle with the vertical theta. So always, so this one is a base for us, and here is a perpendicular. So if you use a trigonometric ratio tangent theta is perpendicular divided by base. So tangent theta will be perpendicular 35 divided by 23. So theta will be equals to 30, tan inverse 35 over 23. So 35 by 23. So what will the answer? In that case, B will be the right answer. And any one of the vector you can draw first, it's up to you, but the result is the angle with a vertical we have to find. If you draw 35 first, if you draw 35 first and then if you draw 35 first and then you drew 23. From tail of the first to the head of the last, you need the resultant. So this angle is not theta here. What angle we need? We need the angle from the vertical. So yeah, we need angle from here. We need the angle from the vertical. We need this angle. That's why even you draw any one of them first, but it will give the same result. Like this will be 35 and this is 23. So this will be 23. So this is not the theta. We want theta here. So this will be 23. As this is 23 here, so this will be 23 and this will be 35. So same result you will get. It won't make difference. Question 11. A non-relativistic particle of a mass m with a momentum p and the kinetic energy ek with another non-relativistic means like it's not moving with the speed of a light, like its mass remain constant. A particle of mass 2m and the momentum p by 2. What is the kinetic energy of the second particle? What is the relation between the kinetic energy and the mass? Like example, ek is half mv square. So the kinetic energy, if I multiply and divide by m, so it will become m square v square divided by m. So we can say Ek is equals to p square divided by 2m. That's a formula. So Ek is p square divided by 2m, the kinetic energy. So kinetic energy is directly proportional to momentum square. If the momentum is half, what will happen to kinetic energy? It will vary with the square, decrease by 4. And if the mass, what is the relation here with this formula and mass? It's inverse. So if the mass is double, it's inverse. So mass is double, like the kinetic energy decreases by 2. So because of the momentum, decrease in momentum, it decreases by 4. And because of decreasing the mass, it is decreasing by 2. So what is the total decrease? The total decrease by 8 because divided by 4 and it divide by 2. So that will become 8. So that's why A will be the right answer. Question 12. A proton in a proton accelerator in electric field and gains kinetic energy, giving it a change in the momentum. An alpha particle accelerate in the same electric field and gain the same kinetic energy. What is the magnitude of change in momentum for alpha particle? So the kinetic energy is same. The formula Ek is equals to p square over 2m. And they mention a proton accelerate, gain kinetic energy, and then alpha particle also accelerate, and it has a momentum delta b. An alpha particle also accelerate and gain the same kinetic energy. But what about the mass of the alpha particle? The mass of alpha particle is 4 times. So Ek is equals to p square over 2m, or if we simplify this equation, Ek into 2m inner root will be equals to p. So if the mass is 4 times, this will be double because it vary with the root. So under root 4 is 2. So what will happen to momentum? The momentum will be 2 times. Because the relation here, you always check Ek is constant. So the relation between the momentum and the mass, it's like under root m is directly proportional to p. So if the mass is 4 times, but it will vary with the root. So under root 4 is what? Under root 4 is 2. So this will increase, but by 2. Is it clear discussion? Question 13. A sphere of a mass m1 moving with velocity u1 collide with elastically with another stationary sphere of mass m2 moving at an angle. Which of the following applies for u1? So momentum before will be equals to momentum after. So, so this will be m1 u1, and here in the x-axis, so this will be m2 v2 cosine theta, and this will be m1 v1 cosine phi. So cosine theta and cosine phi. So it matches with option B because the total momentum, sorry, it matches with option A, sorry, because phi, here m1 v1 it's phi and m2 v2 is theta. So it matches with option A. The horizontal components all are balanced. Question 14, use the same figure. Which of the following equation applies for elastic collision? So for elastic collision, the kinetic energy before should be equals to kinetic energy after. So half m1 u1 square. For kinetic energy, we don't bother about the angles. So it will be half m1 u1 square is equals to half m2 v2 square. And this will be half m1 v1 square. So we add these energies here and that will be equals to initial energy of this one. In 15, which of the following is a possible unit for the change in the rate of change in momentum? Rate of change in momentum is also known as, because impulse is there. Impulse is a change in momentum, but rate of change in momentum is impulse divided by time. Impulse is force into time. So impulse divided by time is what? It is force. So what is the base unit of force? It is kilogram meter second raised to power negative 2.